Hi, in this video, I will be teaching you how to perform vector operations using Python. In this demonstration, I will be using numpy, and I will teach you how to perform vector addition, scalar multiplication, how to get the length of a vector, how to find the distance between two vectors, dot products, solve for the angle between two vectors, and later I will be teaching you how to um, perform elementary row operations in Python. So let's start. Before I start my demonstration, let me just import the necessary packages that I will be needing in my demonstration. And these are import numpy and import numpy as np. So let's try to run this one using this. So basically, I'm just importing numpy and np. You might be using different uh, application to run Python. In my case, I'm using Spider. And what I have here is Python 3.8.5. I suppose it will work or these methods will work on the later versions of Python. Okay, so before we can perform any vector operations, of course, we need to define first vectors. So in my demonstration, let's try to define two vectors. And we will name these vectors as A and B. So for vector A, let's have three components for that vector, and that components are 1, 2, and 3. So we can create a vector in Python using the function numpy.array. So I will store this in the object A, and I will use the numpy.array function. And inside the parentheses, let's have the bracket to indicate that we are now creating the vector. So the components are 1, 2, and 3. So technically, each components are separated by a comma. Next, let's define vector b. So b is equal to numpy.array. So, and for vector b, let's have 2, 5, and 1. We now have the two vectors that we need. So I just simply highlight it and press F9. Now, let's try to perform vector addition. So to perform vector addition, it's simple actually. We have to simply type this. We have to simply type this argument, that is a plus b. And with that, we can now get the sum of the two vector, that is 3, 7, and 4. So that's 1 plus 2 is 3, 2 plus 5 is 7, 3 plus 1 is 4. So perhaps you want to perform vector subtraction. So this is the syntax. Run the code, and we have the result. Now suppose you want to store these new vectors in an object, say C, and we have D. So we use this one, and we highlight the codes. So if we type C, we have the sum vector, and we have here the difference vector. Now let's try to perform scalar multiplication. So scalar multiplication is simple in Python. All we need to do is to multiply the scalar and the vector. So suppose we have the scalar 3 and we want to multiply it to vector A. So we use this syntax, highlight it, and I'll press F9, and I'll get the new vector, that is 3, 6, 9. That is, if you multiply 1 by 3, that's 3. Multiply 2 by 3 is 6. 3 times 3 is 9. Again, let's use vector b, and let's multiply -5 to vector b. So this is the syntax, And we now have the result. It's -10, -25, and -5. Now let's try to compute the length of the vectors. So calculate the length of the vector. We can do that one by using the function np.linalg.norm. So in this function, it only accepts one argument, and that's the vector. So suppose we want to get the norm or the length of vector A. So we use this function, run the code, and we have the result. So for B, we have np.linalg.norm. So B, and we have the answer. That's 5.477. So let's confirm if our answer is correct. So let me just open my calculator. This is my calculator. So remember that the formula for the length of a vector. So the formula for the length is this one. So all we need to do is to get the square root of the sum of the squared components of that vector. So let's try to check the length of vector A. So square root of the squared components. That's 1 squared plus 2 squared plus 3 squared. And that is approximately equal to 3.74, 16, and so on. So for vector vector B, so that's square root of 2 squared plus 5 squared plus 1 squared. And that's square root of 30, or 5.477, and so on. So that's how you find the length of the vector. Now, we can actually round our answer to the nearest decimal value. We can do that one by using the round function. So we have this np.linalg.norm of A, and we want to round it off to the nearest hundredths, so to decimal place. So basically, round function will accept two arguments. The first one is the value that you want to round off, and the next one is the number of decimal place. So in this case, it's 2. So we run the code, and we have the answer. You can also do that one for B. And we want to round it off to the nearest thousand, so 3. So we highlight the code and run the code. And that's 5.477. Next, let's try to calculate the distance between two vectors. And we can do that one using the formula this. So basically, if we want to get the distance between the two vectors, all we need to do is to get the norm of the difference of the two vectors. So I will use the round function because I want to round off my answer to the nearest, say, hundredths. And I will use the np.linalg norm function. And I'll get the difference of vectors A and B. And we have to highlight the code and we run. So it's actually the same. It's 3.74. So to check, let's verify that one using our calculator. So my calculator is here. Basically, we do that one by getting the difference of each component. That's 1 minus 2. Then we square it. Plus the difference of the second component. And square. Plus the difference of the last component. Then we square. That's square root of 14, or 3.74. Next, let's try to calculate the dot product of vectors A and B. And we can use we can do that one by using the np dot function. So it takes two arguments, vectors, the two vectors, so A and B. So you highlight the code and run it. So the dot product is 15. So to confirm if our answer is correct, so remember that the formula for a dot product is this one. This is how we define dot product. So we just multiply the corresponding components, then get the sum of the product. So using our calculator, we can do that one by multiplying the first component, 1 times 2, plus the product of the second component, 2 times 5, plus the product of the last component. And that's equal to 15. Next, let's try to calculate the angle between two vectors. So we can do that one by creating a new function, because as far as I am concerned, there is no function that calculates the angle between two vectors. So we need to create one. Define a function that will calculate the angle between two vectors. So we can define functions in Python by typing def, then type the name of the function. So I will name it vector underscore angle. Then this function will take 3 arguments. First one is the first vector, then the second vector, and the last is the number of decimal. And let's set the default value as 2. Now, in our function, so we need to review that the formula to calculate the angle between two vectors is this one. So we get the dot product of u and v, and the length of u, then the length of v. Then we perform this operation. So let's do that one. So that's cosine theta. So this is an object, and I will store that operation here. So we get the dot product of the two vectors divided by, so we are now in denominator. We need to find the length of the first vector using this function times the length of the second vector. So this is the cosine theta. Next, this is not our final answer yet. We need to get the theta, not the cosine theta. So we will now create a function, or I mean an operation for that. So I will store the object, or I will store the value of the theta in the theta object. And we can use, or we can get the value of theta from cosine theta by using the arc cosine function. So arc cosine in Python, specifically in numpy, is np the dot arc cos. So we have here, we want to get the arc cosine of cosine theta. Now, remember that our angles can be expressed in radian, degrees, revolution, or any other unit measure. So in this, by default, it's expressed in radian. So if you want to convert this one in degree measure, we need to recall the process of converting radian to degrees. Remember that in your pre-calculus, to convert radian to degrees, we need to multiply the radian by 180, then divide it by pi. So pi in Python is numpy dot pi. So basically, the value that will be stored in the theta object will be the degree measure of the theta. Now, let's try to have the answer argument object. So in the answer object, we will try to store the answer that will be displayed by our function. And since we want to round our answer to the specified value of the user, so we will plug or we will put the theta, inside the round function. And as to the num of decimal, it will be indicated by the value in typed by the user here. So that's num decimal. By default, this is 2. And finally, our function will print the answer in degrees. So yeah. So let's run this code. And good. And let's try to use this function to get the angle between vectors A and B. So we type the name of the function, that's vector angle, A, comma B, and say you want to round your answer to the nearest thousandths. So that's 3. So you run the code, and you have your answer. It's 42.952 degrees. So let's try to confirm that one using our calculator. So the formula is r cosine. So we will try to do it in one go. We have, in the numerator, we want to get the dot product of the two vectors. That is 1 times 2 plus 2 times 5 plus 3 times 1. In the denominator, we want to multiply the length of the two vectors. So for the length of vector A, it's square root of 1 squared plus 2 squared plus 3 squared. And for the length of vector B, it's square root of 2 squared plus 5 squared plus 1 squared. So equal sign. So this is in degrees. And the answer is 42.952 or 9519. So it's the same. Now, for the next one, let's try to perform elementary row operations in Python. So I've searched online, and I was able to find a website that gives us the function that will allow us to perform the 3 elementary row operation. And you can access that one here in this website. So credits to the author. So we have here the first function, that is the add row, and I will explain that one later as soon as I copy all the codes. The other one is scale row, and the last one is the switch row. So basically, elementary row operations, we have 3. So the first one is interchange rows, multiply a row by a non-zero constant, and add a multiple of a row to another row. So switch row is the first one. We interchange two rows. Scale row is the second one. And add row is the third one. Now, what happens here is that, let's say for example, let's consider switch rows. This one. What happens here is that it interchanges rows I and j. A here is the matrix. For the scale row, still A is the matrix. K here is the constant or the scalar. And I here is the row. This one. For this elementary row operation, A is the matrix. K is the scalar or the number that you will multiply in row j. So I here is the row I, and j here is the row j. So let's try to apply these functions to perform elementary row operation. So suppose we have a matrix, and let's consider a 3 by 3 matrix, and let's name it as matrix A. We can create a matrix in Python using the numpy array function. So numpy.array function. And we still have this bracket function to indicate that we are now typing the elements of the array. Now, since we want to create a 3 by 3 matrix, we have to create 3 brackets separated by a comma. So basically, this bracket here is the first row of the matrix. This is the second row of the matrix, and this is the third row of the matrix. However, Python does not, when Python counts, actually, it starts from 0, not 1. So as we go through our iterations later, this is the row 0, this is row 1, and this is row 2. And suppose our matrix contains the following components, say 1, 2, 3 for the first row, 2, 3, 1 for the second row, and 3, 2, 1 for the third row. So let's try to run this one, and let's try to see our matrix. So we have here our matrix. It's a 3 by 3 matrix. This is row 0, row 1, and row 2. And now let's try to reduce this one to its reduced echelon form, or reduced row echelon form. So we can do that one. Let me just increase this one. So notice that the first element of, or the first component of the first row is 1. So we can use this one to change this component and this component to 0. So let's do that one. I will now create a new matrix and perform matrix operation. I mean, elementary row operation on this matrix. So to change this one from 2 to 0, I will use the add row function. So add row function. So we type in the matrix, it's A. So K here is -2 because this is +2. I want to change I want to change row 1 and use row 0. So run this code. And we have now the result. So we were able to change this to 0. So let's change this one to 0 using the elementary row operation. So I will now create another matrix. So I will still use the add row function. Now, instead of using the matrix A, I have to use matrix A1 because this is the updated version of A1. I mean, A1 is the updated version of matrix A. So I'll use A1. And to make this one 0 using row 1, we will multiply row 1 by -3. So I will change row 2, rather row 0 earlier. So I will use row 0. Run the code. And this one. And let's check. It's A2. So we were now able to change this one to 0. So next, let's try to change this one to 0 and 0 also. And it would be easier for us if this one is equal to +1, not -1. So I'll need to do something about it. And I can change this one from negative to positive by using the scale row function. So scale row function. So I will now input A2 and multiply this row by -1 to make this +1. And the row I is row 1. So run the code, run, and check. Sorry. A3. There you go. So it becomes +1. Now let's change this one to 0. So we have A4. We'll use the add row function. I will use A3. So since this is negative 4, I'll use 4 as my k. So I here is row 2 and j here is row 1. And let's check. So it's 0. Let's also change this one to 0. So I'll now create a new matrix. Use the add row function. Use A4. And for the value of k, it's negative 2 because this is positive 2. So for my I, it's row 0 and I'll use row 1. So run, check A5. So it's already 0. So next, we will try to change this one to positive 1. So I will create a new object, A6, and I will use scale row function, input A5, and for the k, I will multiply this one by 1 over 12. And for my I, it's row 2. So run the code, check. So it's already 1. So we will use this one to change this and this to 0. So let's start with negative 7. So A7, we have add row. So A6, so it's negative 7. So k here is 7. For I, it's 0. And for j, it's 2. So run the code and check. So it's 0. And finally, change 5 to 0. So I'll create a new matrix, A8. Use the add row function. Input A7. For the k, it's negative 5 because it's positive 5. So for I, it's 1. And I'll use row 2. Run the code. And there you have it. We were able to reduce matrix A to its reduced row echelon form using this function. So I hope you learned something. In the next video, I will be teaching you how to solve systems of linear equation using this function. Thank you very much and have a good day.